much, Carmen. Good morning, ladies and gentlemen. It's a pleasure being here in Seville, and I'd like to thank the first two speakers talking about antiscalants. And this is the third presentation, but it's on a green antiscalant that's newly been developed for reverse osmosis. Traditionally, sort of antiscalants have been based on phosphonate chemistry and polycarboxylates, such as polyacrylates and copolymers. However, a lot of these traditional antiscalants are discharged into the seas or rivers and can be persistent and toxic. So there's a lot of environmental concerns about discharging of antiscalants when used in RO plants, especially where phosphorus and nitrogen containing types of chemistries are used. Then that leads to eutrophication, or as yesterday one of the lady speakers indicated, algal blooms. And with regards to persistence and so on, they have low levels of biodegradability. So we've carried out tests, not we, but we've carried out tests using external government bodies, and we've carried out a test with regards biodegradability. This is an OECD 306 test, and we've compared a number of products. We've compared a polyacrylate, which gives less than 3% biodegradability over 28 days. Two types of phosphonates. One was given 0 and the other less than 7% biodegradability. When we compare this to the green antiscalant Flocon 885, then you get greater than 60% biodegradability. Therefore, within this test, it can be classified as biodegradable. In addition to this, antiscalants tend to accumulate within the aquatic or the marine organisms, and this has toxic effects, which eventually goes into the food chain. And one of the tests that are usually carried out is an OECD 117 test, which is a solubility test between N-octanol and water, and a partition coefficient is measured. If the partition coefficient is less than 3, then it's acceptable for use. And Flocon 885 does particularly well, and it's the partition coefficient is close to 0. So Flocon 885 does not have any possibility of bioaccumulation. So those are the green nature of Flocon 885, but in order to demonstrate its performance, we've carried out a number of tests in our reverse osmosis pilot plant. This is the one that we have in Manchester. This is a schematic representation of the RO plant, where we have a feed tank, low pressure pump, high pressure pump, and then goes through a flow meter into 3 membranes that are in series, and then the reject and the permeate passes through the flow meters into the tank, and we have 2 pressure gauges here. It's a fairly small system and easy to use. The first test we carried out was with a seawater chemistry, and the seawater that was used had a TDS of around 28,000 milligrams per litre, and the recovery in the system was 36%. So in the concentrate, this is the concentration of the brine that would be found, and the potential for calcium carbonate using the Stiffen-Davis saturation index is plus 1.32. The system parameters, as I indicated, is fairly small system, so the flow rate was maintained at 1 meter cube per hour. The pressure was at 60 bar G, and the permeate flux was 0.6 meter cube per hour. We were using a FilmTech seawater membrane. Within all these tests, these conditions remain very similar, with the exception of the recovery. In order to determine the amount of deposition that occurred, then what we did was, when we're cleaning the membranes out, we used a 5% citric acid solution. And that spent solution, we determined the amount of calcium, magnesium, chlorides, anything else that was present. In majority of the cases, the calcium was determined. There was hardly any other ions present when we carried out this work. In order to determine whether we were getting scaling within the system, we ran the unit with no antiscalant. We call this a blank run. And you can see here, within 24 hours period, the recovery dropped significantly from around 30% all the way to 15%, whereas the inlet pressure was maintained, indicating that fouling was occurring. And when you look at the feed flow rates and the reject flow rates and the permeate, you can see here the feed flow rate was maintained, whereas the permeate flow rate decreased and the reject increased, again indicating fouling. We also carried out the analysis of the reject and the feed water, and we determined the calcium levels just to see what sort of profile they gave during the testing. And you can see here quite clearly in the reject it's slowly going down, and there's a rapid drop after about 15 hours. And even in the feed it goes down. The reason for that is that we reuse the feed because we put back the reject and the permeate back into the feed water tank. The salt rejection, you can see here, just starts to drop almost immediately as the test starts. And at the end of the test, when we've cleaned the membranes out, we determine the deposition rate. The deposition rate is determined as milligrams per hour. And in this case, it was 860 milligrams per hour. So under blank conditions, there's rapid fouling of calcium carbonate. We repeated this test with 2 milligrams per litre of Flocon 885, and this is over a longer period of time, close to sort of 330 hours or close to 2 weeks. And you can see here the recovery is almost constant, as well as the inlet pressure. You can clearly see here that the feed, the reject, and the permeate remains constant throughout the 2-week period of testing. Determining the calcium levels, again, in the feed and in the reject remain relatively constant, and the salt rejection remained greater than 99.8% throughout the 2-week period. And when we determined the amount of deposition that occurred within that membrane using the citric acid solution, we determined the rate of 0.002 milligrams per hour, which was almost giving 100% inhibition with 2 ppm, with an SDI of 1.32. We did additional tests with brackish water. The brackish water chemistry is here, with a TDS of just under 1900 milligrams per litre. The recovery we took was 70% in this case, and the concentration is given here with a TDS of just over 6,000 milligrams per litre. Again, we calculated the Stiffen-Davis saturation index, and it was plus 1.43. We used the same methodology of cleaning the membranes using the 5% citric acid. We again repeated the blank run within the RO plant, and you can see here that almost immediately the recovery after 3-4 hours is a sharp reduction in recovery. And with the reject and the permeate, again, you see an increase in reject and a decrease in permeate, which indicates that fouling is taking place on the membrane under these conditions. And when we monitor the calcium, again, the calcium concentration goes down over the 24-hour period, whereas in the feed it's relatively constant. With the salt rejection, in fact, you see an initial rise in the salt rejection that typically occurs when you've got some carbonate scaling, that the efficiency improves, but then afterwards you can see that there is a decline in the salt rejection as there's more passage of the impurities through the membranes. And when we determined the amount of calcium carbonate that occurred under this brackish water condition, then you can see that it was 107 milligrams per litre per hour. This time we did 2 tests. The first test, we deliberately chose a dose level of Flocon 885 at slightly lower than expected to pass. We just wanted to see how long the product would work under these conditions. And you can see quite clearly here that the recovery starts to decline slowly after 200 hours. And with the permeate starting to rise and the permeate decrease and the reject starts to increase. But it can be clearly seen here when we measure the calcium concentration, there is a slight decline, and there's a rapid decline after 200 hours. So it's working up to 200 hours, and then after that there is a loss of calcium in the reject and some in the feed. And this is mirrored in the salt rejection as well, as after 200 hours you see a reduction in the salt rejection. When we determine the amount of deposition that's occurred using 1.2 ppm of Flocon 885, we get a deposition rate of 12 milligrams per hour, which is 89% inhibition rate. So it's not quite there. We're controlling a Stifford-Davis saturation index of 1.43. We repeated the test again with 2 ppm of Flocon 885 in the brackish water, and you can see here clearly that everything remains constant over the 2-week period. Even the feed reject and permeate remains constant. And when you look at the calcium levels, again, within the experimental error, it remains relatively constant in the reject and in the feed. And the salt rejection remains above 99.8% in this test. And when we determine the amount of deposition that's occurred with the 2 ppm 885, you see it's only 0.567, which gives an inhibition rate of 99.5. So 2 ppm of Flocon 885 controls an SDI of 1.43. So in summary, we can demonstrate that the Flocon 885 is ideal for seawater and brackish water, and where environmental restrictions apply can be used. And it's an excellent calcium carbonate inhibitor for both these type of systems. Just for your information, general information, Flocon 885 is unique, biodegradable, and phosphorus and nitrogen-free antiscalant for reverse osmosis based on a polycarboxylic acid chemistry. It's neutralized for ease of handling and transportation. It's certified with the National Sanitation Foundation and the American National Standards Institute, and recently it's been approved by the Spanish Ministry for Reverse Osmosis Systems. It's been used in a number of countries, such as the Netherlands. It's been used in Israel. It's been used in Japan, where environmental restrictions apply. So it's enabled RO operators to continue to operate RO systems and control deposition of scale where effluent discharge limits are of a concern to them. Thank you very much.